Hello, so today we are going to take a look at this problem called permutations with duplicates. So what this problem asks us to do is to return all possible permutations of a list of integers that may contain duplicates. So for example, here we have a list of integers 2, 2, 3, and we want to return all the permutations, but without duplicate, all unique permutations. So for example, here we get 2, 2, 3, 2, 3, 2, 3, 2, 2. We don't get these two 2's here, we don't permute them and get two permutations that have the same organization of numbers, right? And so this is what we want to do. So let's see how we can solve it. Okay, so let's see how we can solve this problem. So let's first pick the example that we have. So that's 2, 2, 3. Right, so usually with permutation here, if we want to solve it, right, we can choose a number, fix it, and then permute the rest, and do that again recursively. And this is one of the famous backtracking problems, so we just apply a backtracking template to solve it. If we take a look at this, if we just do the normal permutations without like doing something special for the duplicates, we'd fix 2, and then permute, and then add to that the permutation of 2, 3, right? So that if we can recurse and then do that one, but that would be 2, 3, and then 3, 2, right? So this would be fixing the first 2. And so this here would give us, with that, we would get 2, 2, 3, and then 2, 3, 2. And then we'll do it again, but this time fixing this 2 instead, right? So that would be 2 here plus permute the rest, which is 2, 3 again. So you can see this will give us the same result. So this would give us 2, 3, and then 3, 2. And this way we'll get as well the same permutations, right? So you can see here, if we just do it in the same way that we do normal permutation, we'll get duplicates, right? So we'll get this one here, duplicates, right? And the same thing for this one here, this is a duplicate as well, right? So we can't do just the normal and if, of course, if we just continue here, this would mean that here we would get 3, and we will permute 2, 2. And you can see here as well, we will get 2, 2, and then 2, 2 again, right? And so this here will give us 3, 2, 2, 3, 2, 2. So again, we would have duplication one more time, right? So and so how can we avoid this duplication, right? So and one thing that with this problem is that the original array is not sorted, right? The original array called nums is not sorted. If we suppose that our input is nums, so we may get something like 3, 2, 4, 2. So we still have duplicates, but it's not sorted. So what we can do is very simple, right? So the main problem here is that when we process it 2, we process another 2 after it. So what we can do is just when we have encounter a number, just process the first occurrence, don't process the rest, right? So this is the main key idea for this is when encountering duplicates, process only the first one, or you could decide to process only the last one and skip all the first ones. Whichever one you would do it, the main idea is to process only one of them. And here processing means just doing this operation here, taking it and then doing the permutation for the rest. That's what we mean by processing. So processing here means take the element in the chosen permutation and permute the rest. Right? So so this is what that means. So what this will mean is that we won't do this step here, we won't do it, right? So we will scratch this, which means we won't get to have these duplicates. So great, we have 2, 2, 3, 2, 3, 2, those are unique. And then here, even also in the recursive solution, we'll process only the first one, and we will not process this one, right? So this one we won't process it, and that way we can would remove this as well. And so with doing this operation by skipping these duplicates here, we can just end up with we'll end up with the following. So this here will end up just with 2, 2, 3, 2, 3, 2, and 3, 2, 2, which is the unique, all the unique combinations here, all the unique permutations here. Okay, so what this would mean is that the step 1 for our algorithm to easily be able to skip, if we encounter an element here, we don't want to have to look through the entire array to find it, and that would be O of n, right? So we can just sort the array first. That way we could have the elements that are equal close to each other. And that way we could just, to check if an element is equal, like if the previous element of an element is equal to it, then we can skip it, right? So basically what we will do here is that for 3, 2, 4, 2, for example, we will sort it 3, 2, 2, sorry, so if we sorted it, it would be 2, 2, 3, 4. So what we can do here is that just we encounter this element, so we process it, but then if we move to the next 2, we check before. So if before it, which means here, let's say I, if nums of I minus 1 is equal to the nums of I, that means we just skip. Because we already process, so we don't process I because we already processed I minus 1 that is equal to it, right? So this is the main idea. So we do the same permutations with for the normal permutation, except if we encounter an element that is equal to the previous element, we skip it so that we don't get duplicate permutations. And that's pretty much it. So let's write this down. So this would be permutations with duplicates. And we'll get an array. So with backtracking, we need two things. We need a couple of things here. Let me write them down here. So we need what is our state that we are going to handle, which is what we are going to pass as a parameter to the recursive function, the backtracking recursive function. We need the base case, and then we need a couple of other operations, which are the core of the backtracking solution. So what are the choices that we are going to make? And for each choice, we need to decide to do what is the choosing step, like how are we going to accomplish choosing, so choose. And then what is the explore step? This would be the recursive call. And then what is the choose step, which would be just reverting the choose step, right? And that's pretty much it. So what is the state here? So for permutations in general, at every step, what we need is, so for example, let's say if I have 1, 2, 2, 3, right? What I know here is that, well, I haven't chosen anything, right? My current permutation is empty. So let's say this color here is permutation, or chosen permutation, right? And then let's pick another color here. Let's say, for example, maybe this one here. This is the remaining element in the array that we haven't chosen yet. So at this step, we haven't chosen anything, so we have the entire array. Because like for example, here when I pick 2, I want to be able to just pick from 2 and 3. And if I pick 3 here, then I should be able to choose just from the remaining 2, right? So that's the main idea here. And so from that 2, 2, 3, well, I have a couple of choices. I said I will skip through over the next one, right? But here, the remaining element would be, so here I would have this, right? And then the empty, it's not the empty list, so here I choose, let's say 2. So if I choose 2 here, what this would mean is that I have chosen 2, so the chosen array contains 2, and the remaining are just 2 and 3, right? And since I skipped the second 2, I don't have a path for it, but I should have a path for 3. So the chosen now contains 3, and the remaining are just 2, 2, right? And so I continue again here. So continuing again here, so I choose only from the remaining, right? And so I have 2 possibilities, 2 or 3, right? So either 2 or 3. So here the chosen is 2, 2, and the remaining is just 3. And here I choose 3, so the chosen is 2, 3, and the remaining is 2, right? And so we keep going. And then here we have only one choice left, which is taken 3. And so chosen is 2, 2, 3. And the remaining is empty, and I'm done, right? And now I go here again. I have only one choice, which is 2. And so my chosen would be 2, 3, 2, and the remaining is empty, so I'm done. So you can see whenever the remaining is empty, I'm done. And then here, I have 2 choices. I can either pick, but since I'm doing with duplicates, so I skip the second 2 because it's a duplicate, right? So I do only 1. So here I have just 2. And that would mean that the chosen is 3, 2, and the remaining is 2. And so here I have only one choice, which is 2. So I get 3, 2, 2. And the remaining is empty. And so I'm done. So you can see we got the 3, 2, 2, 3, 2, 3, 2, 3, 2, 2 by just doing the same, the idea here of skipping over the duplicates and doing the permutation. And so just looking at this, at every stage I needed to know what I have chosen so far and the remaining elements that I need to choose from, right? And so to do, what this would mean here is my state is 2 things, the remaining elements and chosen permutation so far, right? And what is my base case? You can see here I ended processing every time the remaining list became empty. So here what we can say that this is if length of remaining is equal to 0, and in Python we can just say not remaining in this case. Now for each case, for each choice, what did I do here? So for each choice I took the element and I added it to chosen array, right? The red one here, to the chosen permutation. And so what this would mean here is that the step that I would need to do for choose is, well, take chosen and add, in Python that's append the number, right? And what else did I do? So when I chose 2, I added to the chosen, but I also removed it from the remaining because I can't pick it again, right? So I will need to remove it from the remaining, which means here I will need to do remaining that remove the number. Let me just give some space here. So and then we have explore, and then we have and choose here. Okay, so how can I explore? Explore is just recursing what we did here, which is just passing the state to the helper function that has the 2 parameters, so the recursive helper function. So this would be, we would pass the remaining and the chosen permutation so far, right? And the end choose is just reverting the choose step. So for choose, chosen, what the element that we added here, that's the last element that was added, so we can just use pop to remove it, so that would be chosen.pop. And for the remaining, that's just removing the element. So suppose the choice here is I, we have I and we have the number, right? So what this would mean is I could just say remaining dot remove, or dot insert. So I removed it here, so I need to insert it, right? So this would mean insert it at position I, insert I num, right? And so here these are in the enumerate. So these elements are in the remaining, right? So every time, every choice, I make it in the remaining list. As you can see here, 2, 3, I made choices 2 and 3 from the remaining list, right? And so what this would mean is that I and num are in the remaining array. And that's pretty much all I need for my backtracking solution, is to come up with these states, with these values. And so now I can just write it down. So the first thing I need my recursive function, because it has 2 different sets of parameters, remaining and chosen, right? So let's just write that down. We need 2 things. Helper needs remaining and chosen. Now I can write my base case, which is if not remaining, which means remaining list is empty. What do I need to do? I can just have an array, right? I will initialize that array later on. Let's initialize it down here. So, and launch the call to helper. So initially, the first helper call, remaining is all the elements in the array, and chosen is an empty list. And at the end, I could just return the arrays. And so here, if not remaining, I can add the element, I can add the chosen permutation to the list of permutations. So that would be just append. Append chosen. And then here, one thing to note is that I want to sort the array first before passing it to the helper function, right? Because my array assumes it's sorted and assumes to every equal elements are next to each other, right? So that would mean that here I will need to sort the array, then call the helper function, with the remaining being the numbers, and the chosen is empty for now, and then we return res. Now in the else case here, what do I need to do? So in the else case, the first thing I need to do is go through each choice. So I can do for I num in enumerate of remaining. What do I need to do for each choice? First choose, then explore, then end choose. So for first, the choose portion, I will need to add the number to chosen, so chosen.append num. Then I will need to remove it from the remaining elements, right? So what that would mean is that remaining dot remove the number. Then I will need to explore, and so exploring here means calling the helper function again with the remaining and the chosen. Then after that I need to unchoose, right? So unchoosing means reverting the chosen operation here, so that would mean chosen.pop, and then after that I will need to remove the element from the remaining, and the element was at position I, so I can just insert it back, right? So what this would mean is I can insert back in remaining at position I, insert the number, and that's it, I'm done. So that's the only steps I need. Base case, go through the choices, choose, explore, and then insert. So this is just the normal backtracking, right? But I didn't do the skipping over the next element, skipping over this one. Like here, I didn't explore 2, right? I didn't explore 2 here, so I need to do that here, right? So what this would mean is that before, so I need to kind of remove this so that I can do it. So before exploring, checking if the number at position I minus 1 is equal to the number at position I need to skip it. And skipping it here, I can just do continue. So here I just, for I minus 1 to be correct, I need I to be bigger than 0, right? Then continue. But otherwise, we can continue and do the choose and choosing step. So that would mean, let's write it again, chosen dot append number, and then the remaining dot remove the number. And here you could see we skip the next element if it's equal, so we want to explore this 2 here. Same thing here, we want to explore this 2 here, we'd explore it only once. And so after that we need to call the helper, so helper with remaining and chosen, and then we could choose, and with that we'll be done. So let's write this again, chosen dot remove dot pop, right, to remove that element, and then the last step is removing from the remaining, sorry, inserting back in remaining. And that's pretty much it. And so the main difference between this and the normal permutations without duplicates is this step here. Yeah, so that's pretty much it. So again, template of backtracking, and then sometimes you need a modification to remove some choices because the enumeration that we are looking for adds an extra constraint. And so 2 things here we added is the sorting, so that we can have the elements that are equal next to each other. And then this here. And since the number of permutations that we have anyway are n factorial at most, doing an O of n log n operation here to sort, that's really nothing compared to the n factorial. And so this is definitely worth it, right? Okay, so let's code this up, run it on some examples, and make sure it works. Okay, so I wrote down the solution that we just saw in the overview. And so we get a list of numbers, and that may contain duplicates. And so here we just define, like, we actually don't need this, just need the list. And then we solve the array, right? And then we initialize the call to our recursive function that has the 2 states, the remaining number of elements, and the chosen permutation, the currently chosen permutation. And if we reach the base case, which means the remaining list is empty, we add the permutation to the list of permutations. We just copy it here. This is equivalent to doing copy. And we are doing this because later on we modify the chosen array, and chosen we modify it here by popping the element. And so we don't want that to affect the reference to this list that we already added, because that's a final permutation. And so we copy it so it doesn't get modified later. And then we go through all the choices. We remove here we don't process the duplicates, right? So by checking if the previous element was equal to it, that means we already processed I minus 1, if it was the first occurrence of the element, and then we skip the next one. So always we process only the first occurrence of a number, and we ignore the equal numbers after it, right? And since we sorted, the equal numbers are next to each other, right? And so we do that step, the additional step here, and then we do the choosing step, which means adding to the chosen permutation and removing from the remaining elements. We explore by recursing on the recursive function here, and then we choose by reversing these 2 steps of the choosing operation, which means here we pop, so that we remove the latest added element, which is num here, and then we insert back into remaining because we removed it here, and the index was I because we are going through remaining here, so we just insert it back. So that's the main idea. I have here 2 examples that we can run it with, and so let's just run it. So for 2, 2, 3, we got 2, 2, 3, 2, 3, 2, 3, 2, 2, so that works. Same thing with 3, 2, 3, 4, so we source it first, and then we didn't get any duplicates. Yeah, so that's the main idea behind this. There is slight optimization that we can do here, which is we don't actually need to do this step explicitly. We can just do it in the parameter here. And if we do it in the parameter, we don't need to do this either. So we can just comment this out. So first, let's just do the chosen. So instead of adding it and then removing it, we can just pass a new list that has the state that we want, right? And so that can simplify this. For the remaining, instead of removing it and then, so I removed the wrong element, I should remove this instead of this. And so here for the remaining, instead of removing it and then inserting it back, we can just pass a list that doesn't have the element. And so a list that doesn't have the element means we just take everything before I and take everything after I, right? And so that would mean we no longer need these two either. But it's always good with backtracking to write them down, just so that you can get used to the pattern of choosing, exploring, and then choosing. And yeah, so that's pretty much it. So let's run this again. So still, we have the same results. Yeah, so that's it pretty much for this problem. Thanks for watching and see you on the next one. Bye.